This is a video on properties of exponents. We're going to focus on power to a power and quotient and products to a power. So we'll start with if you have a power to a power. So for example, 2 squared raised to the second. Now if you think about what this means, this outside piece means I'm squaring, I'm multiplying this inside piece times itself. Now we could apply the rule where we're multiplying like bases and do 2 plus 2 to get 4. However, we don't really want to have to do that every time, so we want a general rule, and I'm going to show you one more example. Let's do x to the 4th to the 3rd. Again, that means x to the 4th times x to the 4th times x to the 4th, and I'm really looking at repeated addition, right? I'm going to add 4 plus 4 plus 4 to get 12. And hopefully that repeated addition triggers something from your early elementary memory where if we multiplied, we're doing the same thing as repeated addition. So 4 times 3 is the 12. So our general rule here is that x to the a raised to the b is x to the a times b. Now each of these rules goes back and forth. We can reverse that. We can rewrite this way. That's a very helpful trick for looking for alternate ways of solving problems. So our practice problem here is we have x squared to the 3rd to the half to the -3. So it's to a power, to a power, to a power, to a power. We're basically going to keep the x and we're going to multiply all of those exponents together. Now you might recognize right away that 2 and the 1/2 are going to cancel. And if we have those canceled, we have 3 times -3, which is x to the -9th. And if you're comfortable with exponents that are negative, you know that that actually belongs in the denominator. So we actually get 1 over x to the 9th. What happens when you have a product or quotient to a power? So really this is 3x y to the 5th all being raised to the 3rd. Now the long way to do this out would be saying 3x y to the 5th, 3x y to the 5th, and then 3x y to the 5th. And then we could use our properties of multiplying exponents. I don't want to do that. I want to use my new power to a power property. Actually, I'm going to keep that. I'm going to say it's important to notice that each of these actually has an exponent, right? We're going to be multiplying this outside exponent times each of the exponents. So the shortcut for this is going to be 3 to the 1 times 3 times x to the 1 times 3 times y to the 5 times 3. And then we're going to do those multiplications out. To get 3 to the 3rd, x to the 3rd, and y to the 15th. Now the only thing that I would have you do is say, hey, 3 to the 3rd, that's 3 times 3 times 3, or 27. X to the 3rd is fine as it is, and y to the 15th is fine as it is. Let's do one more of those. I'm going to add a negative in here just to make it a little more interesting. Again, really important to notice that we're not multiplying the 2 times the 2. We're multiplying the 2 by the exponent of the 2. So this is going to be 2 to the 2, x to the, I think we're okay just multiplying these values together. That gives me -4, and 5 times 2 for the exponent of the y. Got 2 things to clean up here. I have a negative exponent, which means I will have a denominator. I'm going to take care of the 2 squared, which is 4. I'm going to leave the y to the 10th in the numerator, but this x to the -4 really should be x to the 4th in the denominator. There's my answer. on that second one. It works the same way for quotients. All right, so on this problem, we've got a bunch of unwritten exponents there. If there's no exponent, it is a 1, which is imperative, especially when you need to multiply, because you're not multiplying 3 by 5, you're doing the exponent times 5. So this is 3 to the 5th, x to the 5th, y to the 5th, 2 to the 5th, x to the 10th, and y to the 5th. From there, we look to try to cancel. I see that these cancel perfectly, so I'm going to get rid of all the y's altogether. I have 5 x's here, and I have 10 x's there. That means there's more x's in the bottom. I know that 3 to the 5th is 243. I know that 2 to the 5th is 32. There is my answer. Now, that may not be the way you wanted to approach this. You might say, oh, there's a bunch of parentheses. Let's try to simplify first. Nothing wrong with that. In fact, I think it's probably the way to go. So I'm going to keep the 3 and the 2. I'm going to keep the 5. I notice that there's an x and an x to the 10th. There's 9 more x's in the bottom. And I'm noticing that I made a mistake before. Maybe you caught that. Glad I did this a second time. And then the y's will cancel because it's y over y. And then I'm going to get the 243 over 32 x to the, I'm going to multiply to get 45 here. The mistake I made was that I never multiplied the 10 by 5. This should have been a 50 here, and that should then have been a 45. So 5 here, 50 there, 45 more in the denominator. Everyone makes mistakes.